Hello, everyone. My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled, together with 3dprint.com. I'm the Vice President of Consulting at Smart Tech Analysis, and I'm the Executive Editor of 3dprint.com, and I'm going to bring you the 6 top news items for today. So what we have today, the first one we have today is courtesy of Tech, or well, actually it's called Stakeholder Foods, which I think we should all kind of applaud that name because I do think it's one of the most amazing names ever because they make 3D printed or bioprinted beef and other meats made from like one single cow cell. They're grown in culture and then bioprinted to make the final product. The idea, of course, a lot less land use, a lot less water use, and more ethical. That's the idea. Now, they've recently introduced or today they introduced the Omekase Beef bites. And that's, of course, wonderful because they're, of course, gunning for Wagyu, which for a lot of people have been called the number one steak in the world, let's say, the most desired steak in the world. And they're going to make their alternative, and they call it Omakase, which, of course, is like a Japanese word meaning like chef's choice or something. So they're very creative. So Stakeholder Foods is a very hard charging company, very, very creative and very, very go, go, go. So a great move. The idea is that this is gourmet cultured meat, and what they're hoping to do is customize patterns and customize marbling. So you can get different layers of fat and muscle, and you could change those patterns, um, which by through the 3D printing process. And what they hope is that then there'll be true customized food and have different customized layers, like maybe a chef or you yourself could customize the different layers of the different fat content or the different structures. Um, well, this is all, I think, exciting, but it doesn't move them much closer to the challenge. They also told us that there's a multiple nozzle modular print system they're working on, which they're developing, which makes me more hopeful than this, actually. I mean, I think if we look at these technologies, they're using traditional bioprinting techniques, and they have not scaled them. So the biggest problem these companies have is being able to produce the millions of parts and components that they need to, and doing this in a cost-effective way. That to me is the number one challenge that these guys have. So solving that is important, and we have to realize as a mainstream 3D printing industry might see this as a kind of a sideshow, but the types of equipment they need, the nozzles they need, the control software they need, the planning software they need is going to be required in a huge volume and a huge amount of like quality control, quality assurance. So I think it's real worth it as a firm in this industry look at how you can cater to this meat, the burgeoning meat printing industry as well. Um, the Rayshape has announced the availability of its Edge E1 digital dentistry 3D printer. This is Rayshape is rather close in name to Sprint Ray maybe. It's an LCD mono LCD printer with a 92 by 120 by 190 millimeter build volume. It's said to have a very good high surface quality. And what I like about this is that we're talking, this is a kind of mid-market printer, and they say, hey, the third-party resin is open. So you can choose your own resin on this. So up until now, we've had companies like Envision Tech, now Desktop Mental Health, and Asiga, and they're kind of more industrial systems like $15,000 to $45,000 or to $80,000. Then above that, we have the larger 3D system machines. Now we then have a Stratasys P3 kind of technology that's kind of open and then and in the higher price segment as well. But below that, we've got companies like Elegoo Mars making $200 systems. Formlabs making like several $1,000 systems with specific dental resins. And these guys are going up with a kind of a more market system, a mid-market system with an open resin choice. At the same time, we have companies like Sprint Ray and Star 3D and stuff. They're saying, look, here we have all the software, we've got the material, we've got the printer, everything works together, works together really well, give us lots of money. But having your own resin choice might actually let you save a lot of money if you're a dental lab or chair-side dentist willing to use 3D printing. So this market is going to be a slaughter, and I could not tell you who's going to win at this point. I would go for a lot of dentists now seem to be inclined to take these integrated solutions just because of the ease of adoption. A lot of labs are looking at like a Asiga or open systems and more open kind of things that give them more profit in the long run. Whereas a lot of device makers and other people that want it simple, they tend to go for like the more closed system kind of thing. So it's going to be a slaughter. That's the only thing I can tell you for certain. And this is real space to watch. And I think thought this is interesting to see people coming into this market with, integrated solutions, but open resin choice, and then also having the peripherals you would need as well. So that to me is yeah, exciting news. The next thing is Stratasys, or McLaren is admitted, McLaren F1 is admitted to using Stratasys RPS machines, or what they're now called the NEO 800. It's always nice if the Formula One guys tell us a little bit about what they're doing. They're huge clients of 3D printing, and McLaren's kind of cult to it, which is always nice. They say they have 5 systems, 5 NEO 800s. They use them, as we knew already, but they use them extensively because we knew already that one of the reasons I've been a big RPS kind of fan is because I kept hearing from Formula One teams that they were using them. And for the main use is for wind tunnel testing, to make wind tunnel testing components, especially with specialized resins, such as Somos Preform Reflect, which has specifically been made for the Formula One industry by, well, what's now a part of Stratasys. What's a bit new is they're using these systems to make jigs, templates, small mold components, and parts in the car. We knew already for a long time that they're making certain car parts using serial lithography, but people have always been a bit canny on saying that publicly and also disclosing which parts. So that to me is nice. They've been working on it together since 2017, and they make 9,000 parts a year using 5 systems. Methinks they could do more than that, but maybe they give them a lot of time off or something like that. But at least they make over 9,000 parts a year. And the next news comes to us from 3D Gens, which is a high temperature printer company, and Emery oleochemicals. They've partnered to make kind of a bound metal 3D printing solution. I think it's a brilliant move by both companies to focus on their strengths. Emery Oleochemicals has a binder kind of solution. Been working with the MIM industry, so they know what the MIM guys want. They know about the sintering, which is the big problem with bound metal printing, of course. And 3D Gens can then make the perfect printer for that application. So I think wonderful partnership. We're seeing a lot of movement in bound metal. Mark Ford's growing in the space. Ultimaker has entered it together with BASF. BASF is, of course, pushing it considerably. Nanoe we talked about yesterday. So this also shows that the 3D Gens has ambitions to roll out this kind of technology. Now, it has 2 printers for this, MP260, now the MP350. They're specific to this, specifically made for this technology. And I think this could really become a huge area. Now, a lot of people think, oh, it's not really, it doesn't compare to binder jet, or you can't do the same things to it, you powder bed fusion, but that's missing the point. This is a technology that's great for if you have 1,000 parts, spare parts, so you want to print in 10 different locations, and they're quite rough. They're maybe not as fine mechanical, or they don't need as much detail, because if they're smaller parts and need a lot of detail, you'll want to use binder jet, right? Or if they're really detailed, really small parts, you might want to use slurry SLA, right? Which is another way of getting to the same part, where you have the metal parts in a slurry SLA component, and you sinter that out. If you have bigger parts, you're going to want to use like Shaki, Optimac, Meltio, that kind of stuff. So there's an area there, a family of parts that for a lot of people can be using this for serial production or for production of like a library of parts. Getting to one sintered part is complicated. Shrinkage, wall thickness, that all affects the wall thickness and geometry and part size all affect your shrinkage. And so on. We haven't really been able to figure that out well, so it's going to be difficult to print like a first new part. But if you just make libraries of parts, this is a wonderful kind of technology. So I do think this is going to grow. The next thing is that 3D Systems has launched its QNI 30 or copper nickel 30 alloy together with Huntington Ingalls, Newport News Shipyard. This is kind of the largest builder of ships in the American Navy. The material has been provided by Praxair, which is one American company owned by a non-American company. So this is kind of generally a warm blanket of news for the U.S. Navy, of course, because it's seeing American firms working together on making these technology available. The DMP Flex 350 is the printer that this That's a part of a fusion printer that this material is going to be qualified on. The teams are going to be working together on parameters for this system and this material. And I love this because there's not a lot of people working in marine, and it's going to be such a huge market. And one of the biggest problems there is corrosion resistance from seawater itself and from the spray from salt and all this. And this is an extraordinarily good alloy that's been made specifically for that. And so it's a good alloy to make things like valves, fittings, pumps, pump components, things like that. Not only for just the U.S. military and Navy and stuff, but it could also be used for offshore energy, wind energy, offshore oil and gas, that kind of thing. So this is a good, I think it seems like a niche material until you find out that the U.S. Navy is going to spend the budget of the U.S. Navy is like $230 billion, right? And this move into defense by 3D Systems, I think, is a very astute one. And I think it's a very smart one to be doing it together with the partners that really understand how the system works. The U.S. Navy wants to expand and get 100 more ships. But if we look at that, a lot of the U.S. Navy's current ships are being repaired. And the repair times are sometimes they take 30 days, 60 days, 90 days longer than, or maybe much more longer than intended. So not only does the United States have a lot of its ships out of commission at any one time, which means that any saving of that, any of quicker availability of ships due to faster repair would have a huge impact on their operational readiness and sustainment. But also, it would have a huge financial impact on just how many ships they have to build to get to the levels they want to. And if we look at, for example, imagine the United States was in a war footing or in an actual conflict and they lost 10 ships. Right now, it does not have the capacity in Rota, in Singapore, and Bahrain to repair all these ships, and in the United States. So they're already backed up, right? So imagine if they all of a sudden lost 10 of them, or 10 of them were damaged in a war, in a conflict. How could it repair them all? Right? So this is not only a budgetary thing, this is not only something that would figure in the future budgets of the Navy, but it's also something really affecting the security of the United States of America, in the sense that if you cannot repair these ships, then you're going to have a giant problem. And we must remember that in the history, a lot of ships almost sunk or sunk at Pearl Harbor went on to be repaired and played outsized roles in the further conflict of the war and the winning of the war by the United States of America. This is not just some kind of quaint thing. 3D printing reduces time to part, reduces the time to making parts, and that could really help these guys make some pretty ambitious goals. So, I do think this is, the marine generally is an application where I see too few people playing in. From the alloy side, from the metal side, also from polymers that these guys can use. I think given the potential and given the exact cash that these guys lose if they don't have these things available, these assets available, I think this is an overlooked opportunity, and it's very astute for 3D Systems to work on this. The next news is that Mantle has launched commercially. We love Mantle, I think, at 3dprint.com. We've met with them, we've interviewed them. It's a really great technology. First off, it's kind of like a binder jet thing. It's like a slurry binder jet kind of thing. What they do is they do like a layer by layer drying process, and then they mill every dozen or less layers as well. So it's kind of like if you mix binder jet with like a Sodic or a Matsura machine, hybrid binder jet or something. I don't know what we would call this. Now, the advantage is that it can make different geometries that don't collapse on themselves, which is nice. But what's another advantage, they can make parts that are quite smooth and that have really sharp details on them, or sharp kind of curves and things on them, and also really good details. So, and that is specifically interested for mold tooling. And this is the next thing I love of the company. Now, the technology I think is very interesting. I like the management team. I like the way they sell themselves. But what I super love about this company is that they said, look, you know what? We make sharp parts with good details. Conformal cooling for mold tooling inserts is a good thing. We can work on that. People are going to want to reduce their cycle times. We can help them with that, and that'll really give them advantages. At the same time, they're going to want to reduce their time to market of these mold components due to pressures on just generally, cars used to be in the market for 5 years. Now they get updated every 1 to 2 years. Generally everything is going faster and it's more competitive. So we're going to jump on this tooling market. So we have tool steels, and we're focused on tooling. So I love their go-to-market. I love the idea that these guys don't have a universe where they're like, oh, we need to do orthopedics or cars, and we need to talk to Volkswagen. No. They're literally saying, look, we need to talk to all the mold tooling insert guys at all the big companies in the US. Right? We don't need to talk to the head of R&D. We don't need to talk to the marketing people or the whatever the manufacturing people. We don't have to ride roughshod over their plans. We're just going to say, hey, we have a mold tool insert that's faster, cheaper, and you're going to be able to order these things cheaper from us, or you're going to be able to make them faster and cheaper in-house. That to me is a fantastic value proposition, and it makes everything easier. Instead of you're trying to get into Boeing and then Toyota on the same week, these guys are super focused on their market, and that's what I love most about Mantle. Of course, you could use this technology for different things, but by them developing a market focusing only on that market and now releasing the machine for that, I think is a fantastic. That's just smarter than everyone else. I really do think. The machine that they're making available, the commercial launch thing, it's a $350,000 machine. And it comes at a very timely time. Think about all the defense industry stuff. These guys are trying to make things in America again. The tooling industry is, for a large part, been kind of like the Chinese are the best in tooling in the world right now. That whole infrastructure has moved to China. And for them to rebuild this in the United States to make manufacturing more resilient in the United States, it would be really advantageous for them to be able to make these inserts in-house. And now, well, they probably have, a lot of companies have lost the knowledge of doing this or don't even have the people to do this. So for them to switch to additive is now looking like a very good time to do that. So I think it's a very timely time for Mantle to be releasing the system. And I just think it's a brilliant startup. I really do. Yeah, that's it. I thank you so much for your time today.